Welcome to Chapter 15, Sampling Distribution of the Sample Mean. In Chapter 15, we're going to use two big ideas in statistics, the law of large numbers and the central limit theorem, to build a bridge from what we did in Chapter 3 with that normal distribution and finding probabilities for individuals to working with groups and probabilities related to those, which is the backbone behind confidence intervals and hypothesis testing. All right, so a couple quick housekeeping notes. There are two pre-quizzes for this chapter. There's no Excel, but we will be using that Rossman chance normal probability calculator still. All right, I want to start by adding more detail to our definitions for parameters and statistics. It's really going to help us as we move forward. So both parameters and statistics are values that can be calculated, such as the mean, standard deviation, or correlation coefficient. As we know, a parameter is a number that comes from our population. So if we're able to collect data about every single individual that we're interested in, we can make an exact calculation, which means that the number we get is fixed in value because it is every single person that we're interested in. In practice, this is pretty difficult to do unless you're interested in something that is very specific, like the average height of volleyball players on the Western volleyball team. Otherwise, what happens if we're interested in something like folks with diabetes, that population is so large that it's very difficult or costly to find that exact value. So if you are able to find that exact value, like the average height of the volleyball players on our team, then you've calculated a parameter, and it turns out you don't actually need the field of statistics. You have the number that you're looking for. What the field of statistics does is it allows us to use a sample to make estimations about our population and its parameters. So a statistic is calculated from the sample data. Since each random sample is slightly different, that value is going to vary or change based on the sample. However, those values are usually close together. So as worrisome as it sounds that they're slightly different, it's okay because if used appropriately, these can help statisticians estimate unknown population parameters, such if we're interested in the average height of everybody in the state of Colorado. Right, so there are some examples of some parameters and statistics at the bottom. So population is our parameters, and so when we calculate our mean, we use mu. For calculating mean from our sample, we'll use x with a bar over it. So these should look fairly familiar. We've touched on these before. And what I'd like for you to do is you have three examples in your notes. I'd love for you to go through and identify, are these something that's calculated? So is it a statistic or parameter, or is it neither? It's still an important number or still a useful number, but it doesn't fall into that category of parameter or statistic. So go ahead and pause the video and work on all three of those. All right, so hopefully you gave those a try. Let's go ahead and go through them together. So first one's on genetic engineering. Here's an idea for treating advanced melanoma, the most serious kind of skin cancer. Genetically engineer white blood cells to better recognize and destroy cancer cells, then infuse these cells into patients. The subjects in a small initial study of this approach were 11 patients whose melanoma had not responded to existing treatments. One outcome of this experiment was measured by a test for the presence of cells that trigger an immune response in the body and so may help fight cancer. The mean counts of active cells per 100,000 for the 11 people that were in the study were 3.8 before infusion and 160.2 after infusion. So you have three numbers to look at here. These last two are probably the easiest right off the bat because these are coming from that 11 people in our sample. And it says they calculated an average or mean before and after. So we know it's calculated, we know it's coming from the sample. So that 3.8 and the 160.2 are both going to be considered statistics. The other number we have here is the 11. The 11 is actually technically going to fall under the neither category, though if you put that under the statistic, I can certainly understand where you are coming from, because that number really does represent something from the sample. It's just the number of participants there. So it's not a calculation so much as a count. Okay. Florida voters. So Florida played a key role in recent presidential elections. Voter registration records in February of 2014 show that 39% of Florida voters are registered as Democrats and 35% as Republicans. Most of the others that aren't represented out of that did not choose a party. To test a random digit dialing device, this is where the phone just systematically calls one phone number after another, that you plan to use to poll voters for the 2014 Senate elections. You use it to call 250 randomly selected residential telephones in Florida. Of the registered voters contacted, 34% are registered as Democrats. So we have four numbers in this one. At the very top, it says that voter registration records state the following. So voter registration records are, in fact, a form of a census, right? That tells us everything about all of the eligible people that are allowed to vote. So that 39 and that 35% are both going to be parameters. And then that leaves us with two numbers left, the 2014 and the 34%. It says of the registered voters contacted, 34% are registered Democrats. So of the ones contacted is indicating the sample, so that 34% is going to be a statistic. And then 2014 is a year, not a calculation, so that'll fall under neither. Right, in our last example, researchers surveyed 500 American anabolic androgenic steroid users ranging in age from 16 to 62 and found that of the ones they contacted, 98.8% of them were male. The proportion of all Americans between the ages of 16 and 62 who are male is 50%. The median age at which those surveyed began using steroids was 22. All right, so we have three numbers to look at. We'll start with that first one, 98.8. So it says they contacted 500 American steroid users, and from that, they found in that group 98.8 are male. So it's calculated from our sample. That'll be a statistic. Then it says the proportion of all Americans between the ages of 16 and 62. So that's tending to get at that idea of our population. So that 50% is going to be a parameter. And then the last one, it says the median age at which those surveyed began using steroids was 22. So median is a number that we calculate. And since that came from our sample, that's going to be a statistic as well.